All right, today, method number one for solving systems of linear equations, we're going to solve by graphing. So not only do we want to be able to solve by graphing, we also want to be able to write some inequalities, systems of linear inequalities, and see how it kind of can pertain to real life. System of linear equations is a set of two or more linear equations in the same variable, like we saw yesterday with our 5-1 lab. Then our main goal is not just to see two equations at once, it's to find the solution. So again, the solution is an ordered pair. It actually works for each equation, or like we saw yesterday in our lab, we're looking for this point of intersection between the two graphs. We talked about it as the break-even point yesterday, but today we're just looking at it the intersection point. So you have two steps and a third down here that's somewhat covered up. So step one, you're going to graph each equation in the coordinate plane. Not bad. Ooh, this word I don't really like. Estimate the point of intersection. You really want to be very precise on that, because if you estimate it and you go back and you check it in step three and you're wrong, then you got to go back and repeat it and re-estimate and then recheck. So be very careful and precise that you get it right the first time. And I'll talk about that checking, what that means. It just means subbing in. You'll see what I'm talking about. So here we go. Solve by graphing. What we're going to do is we're going to remember back a couple of chapters ago talking about slope-intercept form. So I'm going to write that right underneath here. Y equals mx plus b. Oh, I see one here that is not in y equals mx plus b. So switch that to adding the opposite. Please note, write that on in your notes, and then we're just going to solve each equation by graphing. Go as quickly as I can here so that way notes don't take up too much time, but I do have a note to myself that these did take a while. So start right away. First line, our y-intercept is at 2, so put a dot there. Do my best I can here with my presentation. And now we've got this m, slope. Remember that was rise over run. So if I have a -2 slope, that means I'm going down 2 over 1. And just keep on going. Down 2 over 1, down 2 over 1, down 2 over 1. And yeah, when using solving by graphing, be obnoxious. Put a whole lot of points in and just hope that we can hope and pray that our intersection point is over here. If not, we'll have to extend the line going backwards by going left 1, up 2. But we'll do that later. So here we go. Next one. Here we go. Y-intercept at -3. So put a dot there on -3. And then we got a lovely slope, this time of just 3, which is 3 over 1. So I'm going to go up 1, 2, 3 over 1. Oh, that's nice. You see it right away. Right there, I got the same point on both my red and my blue one. But just for practice sake, let's continue going on the red dot one, going up 3 over 1, up 3 over 1 for our rise over run. And you're just going to keep plotting points until you find this point of intersection, which is wonderful. We've got it right there. So that's what we're looking for. Now be very careful. That ordered pair is 1, 0. So now it says, after we've estimated that, now it says to solve by substituting back in, by checking. So what we're going to do is, what happens when we plug that on in? Does it work for both of them? So for the blue one, here is our equation that we talked about. From above, you can see it was y equals -2x plus 2. So plug it on in. We've got the number 0 equals a -2 times 1 plus 2. Do we get that truth statement when we plug it on in? When you take -2 times 1 plus 2, this simplifies out to 0. 0 equals 0. Hey, that does work for that equation. Awesome. Bad news, when it says to check, do it in the other equation as well, which means over here to the side where I have a little bit more room, I'm going to write it in. Y equals 3x plus a -3. So write it on in. Again, plug in those points. 0 is your y value coming right from the point here, and your x value coming from the point. Plug it on in. So one fatal swoop, you can do it. 3 times 1 plus a -3 gives us 0. Is that true? Does 0 equal 0? Hooray! Okay, then we are right with that point. That is what you're looking for. 1, 0, that is the intersection. That is the solution to this system of linear equations. Same thing, rinse, lather, repeat. Put on underneath, between these two, y equals mx plus b. Anyone that isn't in that form, switch to adding the opposite. So you're good to go right away. First line, 14. Ooh, my graph only goes to 10. So you could try to estimate it down here, but instead of doing that, let's just instead move on to a different point. So I want to move over to, just because this is a negative, if I plugged in 1, here, negative 5 times 1 plus 14 is going to give me negative 9. So that's where this point came from. And now, again, my slope, I don't need you to write down rise over run this time, but here it is. Negative 5, over 1. Well, that's a bummer. I can't write it this way. I'm out of space. So I'm going to have to go backwards. I'm going to have to go in reverse. So instead of going down 5 and right 1, I'm going to do the opposite. Instead of going down, I'm going to go up 5 and left 1. Be careful when you count, because if you count wrong, then you're going to miss the point of intersection. So be very careful. 5 over 1, and yep, be obnoxious. Do it again. Up 1, 2, 3, 4, 5 over 1. Up 1, 2, 3, 4, 5 over 1. Put a bunch of them in because you really want to find that point where they intersect, which with our chapter in our lesson right now, they should be nice. And one of these points should be it. So here comes the next one. Y-intercept of 10. And then a slope of, okay, remember, what's in front of the x? What's that coefficient? 1, if you were there. I was hoping you'd say 1. If not, that's fine. So a slope of 1 is 1 over 1, which means from your y-intercept, you're going to go up 1 over 1. Oh, look at that. Isn't that nice? Oh, and then you could keep going if you wanted to, but you already ran into your point of intersection, which is awesome. It's right there. So write that point out. Be very careful. It is a positive 1 and negative 9. That is our solution. Now again, if it says to check your coordinate, that means you're going to plug it on in. So that first equation, it was y equals a negative 5x plus 14. Plug it on in. So for the y value, negative 9 equals negative 5 times your 1 plus 14. And then in that right there, you can do it all in one fatal swoop. Use a calculator or mental math. Negative 5 times 1 is a negative 5. Add that to 14, you get negative 9. Hey, does negative 9 equal negative 9? That's a truth statement. Awesome. That is correct. And do it again for the next equation. I'm going to slide over here where I have a little bit more room. Again, y equals x plus a negative 10. Plug it on in. You've got, for that y value, again, coming straight from the point here, negative 9 and the 1. When you plug them on in, negative 9 equals negative 9. Ding. That is correct. You have the correct point. Solving by graphing, the graphing part is not so difficult or so tricky or takes a long time. It's this checking over here that takes a little bit of work. Got to plug them on in and double check those answers. Then every once in a while they're going to give you one like this, solve by graphing. Well, it's not in slope-intercept form. We want it to be in y equals mx plus b. So quickly, rewrite it. If it's on your assignment, you're going to write down this. You're going to write down the slope-intercept form, y equals mx plus b. If not in that form already, then start rewriting from there. So let me get my eraser here. Oh, since it's not letting me erase on my tablet. Boom, here we go. And picking it back up. I want to start with this bottom one. To get it into y equals mx plus b slope-intercept form, I'm going to add a negative x to both sides, which is awesome. Y equals a negative x plus 1. Done with this guy. This one on top here is going to be a little bit more tricky. I see subtract, don't subtract. Everyone, add the opposite. You're welcome to say that out loud. If you didn't, that is A-okay. Moving on. Adding a negative 2x to both sides to get rid of it. So now I've got, I don't have to jump down here, excuse me, so I've got room. Ooh, don't lose that. Opposite, or negative y equals a negative 2x plus a negative 4. Then to get rid of that negative, remember there's like a negative 1 there, so divide everything by negative 1. And everything means everything on the right side. So negative 2x divided by negative 1, and negative 4 divided by 1. Excuse me, negative 1. So you get 2x plus 4. So we're going to look at those two. So this guy and this guy are what we are going to graph. Again, slope-intercept form, starting with the red one on the bottom, going to a positive 4. Careful, go to a positive 4. And then that slope is 2. 2 over 1. Up 2 over 1. Up 2 over 1. Oh, let me do that one better. And we'll just go that way. Oh, that last one up here missed it just a little bit, but that's okay. We'll just kind of go with it because my tablet and device are not communicating very well. And from there, we've got a slope or y-intercept of positive 1. And then on the blue one, a slope of negative 1, which is negative 1 over 1, which means down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Oh, bummer. They didn't intersect anywhere over here. So starting with the blue one, I'm going to work my way backwards. So that's, instead of going down 1 and right 1, we're going to go up 1 and left 1. Up 1, left 1, up 1, left 1, up 1, left 1. Being obnoxious, I know, but that way I can find it a little bit easier and I can find where my intersection point is. Going back to the red line, instead of going up 2 and right 1, we're going to do the opposite. So go down 2, left 1. Oh, that is so convenient. There it is, our point of intersection. Be very careful that you get that one right when you write it down. It would be negative 1, positive 2. And for time's sake, on note purposes, I am not going to check that into the problem, but you can just plug it on in. So you just do that very quickly. You would have that in both equations, whether you wanted to plug it into these original ones up here, or in here, you plug in your x value for your x and the y for the y and get a truth statement. 5 equals 5. Negative 2 equals negative 2, and you know you've got it right. Last one, word problem. So, for whatever reason, you're keeping track. You're on ESPN, and you know that a football player makes 1 point for an extra point and 3 points for a field goal. You know he kicked 6 times, and you know he has a total of 12 points, but somehow you forgot when you were watching the game how many extra points he made or 3-pointers he made. So the field goals. So it says here to write and solve a system of equations. Here's how we write a system of equation. I see some information given to us right up here. 1 point for an extra point and 3 points for a field goal. Do we know how many extra points he made or how many field goals he made? Nope. So bummer. You're going to have to pick a variable for each of them, x and y. And since we're here together, not really here together, I'm just going to write it down myself. 1x, because it's the first one up here, plus 3y. So we got 1 point for an extra point, 3 points for a field goal. How many total points did he get? Right there it was, 12. So it gets 12 total points. Great. That's only one equation. Now we need a second one. So what we know is this one right here. He has 6 extra points and field goals, some combination thereof. So start with the x plus some number of y field goals, and that is supposed to equal 6. Hey, looky there. Now you have a system of equations. Awesome! But, bummer, it did say to solve that. And today we're solving by graphing. So you should have one more of these on there. So just copying those equations over. Any order will do. Equals 6x. Oh no, they're not in y equals mx plus b. They're not in slope-intercept form. Oh well, we can fix that very quickly. So just rewriting them again. Solving for y. So I'm going to do that by getting rid of this x here. Adding a negative x to both sides. Ran out of room, so I'm going to write that down here. Y equals a negative x plus 6. And doing the other one as well. Here we go. Add a negative 1x Add a negative 1x. Oops, ran out of room. I'm going to come down here. Oh, interesting. 3y equals negative 1x plus 12. Awesome. But hey, don't forget about that 3. Get rid of that 3. So divide everything by 3. So you finally get down here. I know it's a little bit of work, but we got there. Y equals negative 1/3 x plus 4. So once again, we're going to use this equation and this equation, which are now in slope-intercept form, to graph. You could graph by using your intercepts as well up here, a method we found, but there's a lot of work to do there. So just switching them over to slope-intercept form very quickly. And here we go. That top one, I have switched over into black for some reason. So again, count very carefully. 1, 2, 3, 4, 5, 6 is your y-intercept. Slope of negative 1. Down 1, over 1. Down 1, over 1. I'm going to be obnoxious and just keep going. There we go. That was that one. And then coming back to the one that now is purple down here. Again, slope-intercept form tells us that here's your y-intercept. So I'm going to go to the 4. I'm going to count carefully. 1, 2, 3, 4. And then I've got a slope. Oh, interesting. I have a slope of negative 1/3. So that means I'm going to rise negative 1 and run 3. So go down 1, over 3. 1, 2, 3. Oh, looky there. We already found one. But just to be obnoxious and continue the pattern so we can remember to plot points. Down 1, over 3. 1, 2, 3. Down 1, over 3. Hooray! But there we go. There it is. That ordered pair, write it on in. That is your answer. That ordered pair, by my counting. 1, 2, 3. 3. Wish we were together so I can make sure that you agree, but I'll count again. 1, 2, 3. Up to 1, 2, 3. Awesome. So wait a second. That's your answer. Now what if it says, explain the meaning of that? Well, go back to our equation. What did the x stand for? It was attached to this 1. 1 point stood for extra points. How about the y? The y was attached to the 3, which was attached to a field goal. So this point means 3, 3. He made 3 extra points, and he also made 3 field goals. One example of a real-life way of solving equations, systems of linear equations by graphing. There's the assignment 7 through 16, 20, 21, and 28. As per usual, if you have questions, see me before or after school.